got 5 things I want to run through on the latest update to WARDCAM, and this is from October 24, 2021. So first of all, I have seen situations where, due to either part geometry or poor programming, when there's an unwind in a part, that WARDCAM's not printing a feed rate on the first line of code after the unwind, which can cause the cutting head to take off at a high rate of speed. So for example, I'm just going to put a bevel cut on this center hole for right now, and I'll intentionally put it in the wrong spot so we get unwind here. And I'm going to turn off taper comp for right now. As I put in my other video, we've moved the taper comp button over here to make it a little more intuitive. That's related to tool stuff, so I'm just going to turn that off right now. And we have an unwind on that center bevel. And if we search for that unwind, so hits this point here, unwind. Of course, since I've got the newer version, I've got the modal feed rate turned off. So let me go back up and show you what it would be like on the older versions. On the default tab, and of course you have to do scroll lock to enable this, or see it. So now I've got my scroll lock on, default tab, scroll down to modal. So older versions of WARDCAM, this is turned on so that when you create your code, if a feed rate on the next line of code is the same as the previous, it won't print the feed rate. So get a situation like this where it does the unwind, and then on this line here where there's no feed rate, it'll go off at a high rate of speed. So yes, in this latest version of WARDCAM, I've edited the variables file for the Apex machines such that by default modal feed rate should be turned off now. So therefore, when you go to do that, it will put the feed rate on that line of code after the unwind. So I should avoid that. So that's one thing. Next thing is we do have now under options, edit variables, on the WATERJET tab, options down towards the bottom for putting in codes to turn the pump on and off at the start and end of the program. So, and these ones are normally visible even if the scroll lock is off, but if you want to turn the pump on at the start of the program, you can turn that toggle on. If you want to turn the pump off at the end of the program, you can turn that toggle on. And then you've got the codes for pump on and off here. You can also set different dwell times for the ramp up to low pressure and high pressure at the beginning of the program versus if you're in the middle of a program. So if you go up to the dwells area, there's now dwell after pump on if you start the pump in low pressure, and you can have a dwell after pump on high pressure. So those are now separate from the other dwells that we have, where if you're in the middle of a program where it might not take as long to go from high to low pressure, you can have different dwells. So you got this dwell after high pressure, so this would be in the midst of a program when we're changing pressures. So maybe that one only needs to be 20 and this one might only need to be 15, whatever the case may be. So you can have 4 different dwells for those different switches between low and high pressure. And then you've also got the choice of whether you do want the pump to start in low pressure. So that one is down here. So if you want to start the pump in low pressure, you can turn that one on. But since this will be aluminum, we'll just leave that as it is right now. So now if we make this we've got our pump on code at the start there with the 45-second delay, and then at the end got the pump off. And another option in the variables area that's been added in the past couple months per customer request is an option to prompt for work offset position. So this is again on the default tab, and scroll down to the P area, and this one is normally not visible if the scroll lock key is not on, but we'll turn that one, make that one visible. So if you turn this on, when you create your CNC file, you'll get a box like this. So if you just want to stick as a G92 program, you can, or you can type in whatever work offset. Doesn't have to be uppercase G. We go ahead and convert that to uppercase anyways, not that it matters. So now we'll have a G54 at the beginning of the program. And then I've cleaned up the glass cutting options. So for those companies that are doing things like shower doors, where we want to go to a location to open up the cutting head, drop the pump down into low pressure with the cutting head open and such, and then come back and cut the part, where we do a G59 position for that purge location, and then we typically will cut the part based off of a G54 work offset position. Under options, again, edit variables. Over on the WARDCAM tab again, scroll down, and we've got the glass cutting option, which of course we can make visible again. So if we turn this on, then the cutting head will, at the beginning of the program, go to its G59 pressure purge location and go through its pressure purging procedure, PPP. So this is the code that is going, so G59 position, so it's going to lift up to 2 inches above whatever the G59, so you do have to watch this, make sure that that is lifting up high enough. So depending on the different surface levels that the person's cutting on, you may need to increase this number to avoid the cutting head just going straight down into whatever the cutting head might be above when it goes to G00Z2 above G59, so just keep an eye on that. And then it's going to go to the G59 X0Y0 position and then come down to Z0. And so we'll go ahead and save that. And so now if we go ahead and switch to glass, I'm just going to do a different shape here, simpler shape. I'll just do this shape here. So we'll choose our glass material. So, and when we do our actual part, we're going to work that off of G54. So we start with our G54, turn the pump on in high pressure, switch to G59, Z2, go to Z2 above G59, rapids over to the purge location, comes down, opens up the cutting head, drops the pump into low pressure. M00 if they don't have the smart meter mini hopper, so you can manually adjust the abrasive flow rate, turn the water and the abrasive off, switch to G54 work offset position, lift up to 1 inch above that, and then go over and start doing the circular low pressure piercing for that. And then at the end of that, switch to high pressure, M00 to adjust your abrasive flow, lift up 1 inch, and then comes down and pierces through that location where it is to do its pierce on the inside. So there's that. And then finally, last week, customer emailed over a part that looked something like this. That was a little bit of a challenge to get programmed. So they had a bevel, 45-degree bevel on the center hole, and then the rest of it was taper comped, no bevel cuts, but just taper comped. So ended up with a bunch of unwinds on this because of combining the taper compensation with the bevel cutting. So we'll just switch this to 1/4 inch aluminum. So they had a 45-degree bevel cut switch. They put their lead in over here, which was good. Then we enabled taper angle control and ended up with a bunch of unwinds because of where these lead-ins are located. So for example, on the first cut, which is this one here, so this one is, for example, starting at a C angle of positive 62. So if you can envision this, the cutting head is going to be pointing, essentially tilting towards, would be about the 7 o'clock position to compensate for that the taper angle. So that gives us a C angle of 62, and as it's going around there, it's going to unwind. And then same thing on this one here, we're starting at a C of approximately minus 90. So that was that one there, we did not get an unwind. Is that one? No, I'm sorry, that's after it did the unwind. And then on the next hole, we start at, again, C of 17 and so on. So a bunch of unwinds based on where the lead-in locations are on these slots. So if you are combining both bevel cutting and the taper angle control in the same part, a little bit trickier as far as where you have to place your lead. So essentially on this first hole here, we want to look at putting this lead more somewhere along this edge here, because again, this one here, the cutting head is now going to be pointing slightly to the right, which should give us somewhere around a C of negative 180, and then something similar on this one. If we put this somewhere down here and put this one over here, and I think that one would have been okay. So this one over here, we want to have that lead in over here. So you do have to, of course, be careful that it doesn't do a height setter over here. If it does a height setter on the countersink and does that first, and then depending on the diameter of this and what the stamping distance is set for, if this were a large diameter hole, you may want to come down and do a height setter again. So you'd want to avoid that by increasing the stamping distance. And then put this one over here somewhere. This one should be okay where it is, but I'll just minimize the rapid length, and this one maybe here. So this one on the outside, if we have it here, it's going to be basically C of, I believe, 45. And if we have it this way, it's going to be tilting to the left, which would be like C of 0. And this would be probably negative 45. This one will be 270. It actually works in this position here, so you'd want to basically have it anywhere along this area here. So I'll put that one down here. And of course, we'd want to go through and reorder these cuts to minimize some of those rapids. I won't do that right now, but we'll go ahead and create this file now. And hopefully it looks like we don't have any unwinds. So thought that was kind of a fun one to puzzle through. So if you have any questions on that, let me know. Thanks.